Good morning everyone. I am here for class 12 today, and this is lecture number 3, and I'm going to talk about invertible functions today. Okay everyone, just see, when we're talking about the invertible functions, basically any given function is said to be invertible if and only if it is an 1 onto function. It means bijective function. Okay, so only bijective function is said to be invertible function, otherwise not. Okay, hence to prove whether function is invertible or not, we have to prove it is 1 function. Okay, first of all we have to prove it is 1 function. After that we have to put it is also an onto function. Okay, as we had discussed about the 1 function and onto function earlier. Okay everyone, now let's see an example. Consider the function f defined from real number to real number given by fx equals to 4x plus 3. Then you have to show that it is an invertible function. So for the invertible function we have to just check whether function is 1 onto or not. So first of all we have to check 1 and up. We know very well that how do we check the 1 function. Okay, so here fx is given, which is equals to 4x plus 3. Now we have to find fy. Here fy equals to 4y plus 3. Now put fx is equals to fy. After putting fx equals to fy, what we get? We get 4x plus 3 equal to 4y plus 3. So 3 is going to be cancelled. Now we left with 4x equals to 4y. So 4 is also going to be cancelled. Okay, from both sides. So we left with x equals to y. Now we get only one solution. It means x equals to y, and for here and here for every y we have only one value of x. So that's why function is an 1 function. Okay everyone, now this function is 1, so we have to check it is onto or not. So for onto function we have to write y equals to 4x plus 3. Okay, after that we get 4x is equals to y minus 3, because we have to write x in terms of y. After writing x in terms of y, we get x equals to y minus 3 upon 4. Now y is belongs to the real number. Okay everyone, and here expression x equals to y minus 3 upon 4 is an linear algebraic expression, and for every y belongs to real number x must be defined. Okay, that's why this function is an onto function in real number. So we can say that this function is 1 onto function. It means it is an invertible function. Okay everyone, good. Now see the next example. Example number 2. If function f defined from R minus set of minus 4 by 3 to a real number. Okay, it is given is a function defined by fx equals to 4x upon 3x plus 4 is non-invertible function. We want to prove that it is not invertible. Okay, so let's see. First of all we have to check for 1. So here fx is given 4x upon 3x plus 4, so we get fy equals to 4y upon 3y plus 4. Now for checking we have to put fx equals to fy. After putting fx equals to fy, we get 4x upon 3x plus 4 equal to 4y upon 3y plus 4. Now after cross multiplication we get 4x in bracket 3y plus 4 equals to 4y in bracket 3x plus 4. After opening bracket we get 12xy plus 16x on left side equal to in right side 12xy plus 16y. Now 12xy is the numerical value on both sides, so that's why this is going to be cancelled. So we left with 16x on left side and 16y on right side. So 16x equals to 16y. 16 also going to be cancelled, so we left with x equals to y. So here for every y belonging to the domain x have only one solution, so this function is a 1 function. Okay everyone, now for onto function. For onto function, as you know very well that we have to find the value of x in terms of y. Here y is given, which is equals to 4x upon 3x plus 4. After cross multiplication we left with 3xy plus 4y equal to 4x. Now 3xy minus 4x equals to minus 4y. X is going to be common, so we left with x in bracket 3y minus 4 equal to minus 4y. So we get x equals to minus 4y whole upon 3y minus 4. Now this is an rational algebraic function, so we have to put denominator equals to 0. After putting denominator equals to 0, we get y equals to 4 by 3. So we get the range is equals to r minus set of 4 by 3 and this is not covering the given range of the function, which is R. So that's why this function is not an onto function. So we can say that the given function is non-invertible function. Okay everyone, good. Now next, see the next example, example number 3. Let a function f defined from positive real number to minus 5 to infinity, given as fx equals to 9x square plus 6x minus 5. Then we have to show that f is an invertible function. Okay, so for one function over here, fx equals to 9x square plus 6x minus 5, it is given. Good. So we have to find fy. We get fy equals to 9y square plus 6y minus 5. After putting fx equals to fy, we get 9x square plus 6x minus 5 equals to 9y square plus 6y minus 5. So here the minus 5 is going to be cancelled. Now 9y square going to be shift onto the left side. So we left with 9x square minus 9y square plus 6x minus 6y equals to 0. Now 9x is 9 going to be cancelled from 9x square minus 9y square. So we left with the x square minus y square. And the 6 is common from the second terms, x minus y. We left in the second term, so we can take x minus y now common. After taking x minus y common, we get x minus y in bracket 9x plus 9y plus 6 equals to 0. So here x minus y equals to 0 and 9x plus 9y plus 6 equals to 0, which is not possible because x and y both belongs to the positive real number, and the sum of three positive real numbers never be 0. Okay, so that's why we get only one solution, which is x equals to y. So that's why this function is an 1 function. Okay everyone. Now for onto function, we have to write the given function as y equals to 9x square plus 6x minus 5. After shifting y in right side, we get 9x square plus 6x minus 5 minus y equals to 0. Now we have to compare from ax square plus bx plus c equals to 0. So we get a equals to 9, b equals to 6, c equals to minus 5 minus y. Now we have to apply the Siddhacharya formula, which is minus b plus minus under root b square minus 4ac upon 2a. We have to put the value of a, b and c. So we get x equals to minus 6 plus minus under root 36 minus 4 into 9 in bracket minus 5 minus y whole upon 2 into 9. So we get x equals to minus 6 plus minus under root 36 plus 180 plus 36y whole upon 2 into 9. So we get x equals to minus 6 plus minus 6 is going to be common from the under root because 36 is common. Okay, so after taking square root we get 6 is going to be out. So we left with x equals to minus 6 plus minus 6 under root 6 plus y whole upon 9 into 2 is 18. Now after taking 6 common from the numerator and cancelling from denominator, we get the value of x equals to minus 1 plus minus under root y plus 6 whole upon 3. And here x belonging to the positive real number, so that's why we have to neglect the negative solution. So we let with x equals to minus 1 plus under root y plus 6 whole upon 3. Okay to all of you. Now as you know very well that here x is an irrational algebraic function and it is defined if and only if the quantity inside the square root must be positive. So y plus 6 should be greater than or equals to 0, hence y is greater than or equals to minus 6, means y belongs to minus 6 to infinity. Now this obtained range minus 6 to infinity is covering the given range minus 5 to infinity. So that's why this function is an onto function, hence it is an 1 onto function under the given condition. So the function is invertible function. Okay everyone, so you have to just write down onto your copy. Now next, inverse of any function. Okay, after checking whether function is invertible or not, we have to just talk about how to find the inverse of any given function. So here there are three methods to check whether function is, what will be the inverse of the function. How to find the inverse? By using these three methods. Just see first method, by mapping. Okay, let an invertible function f defined from a to b. It is an invertible function, it means inverse of this function can be exist. Okay, then inverse of the function is obtained by converting range into the domain and domain into range. It means domain of the function converting into the range and range into the domains. It means f inverse going to be defined as f inverse defined from B to A. It means range converted in domain and domain into the range. Okay, for example, let a function f defined as a3 b4 c2 d1. So after taking inverse, what we get? Domain converted into range into domain. It means we get f inverse equals to braces 3 comma a 4 comma b 2 comma c and d comma 1. Okay, let's see the mapping also over here. So by this way we can find the inverse of any function by mapping. Okay, let's see the second method, inverse of function by graph. So here inverse of any invertible function is obtained by taking image from the line y equals to x. Okay, we have to put the mirror along the line y equals to x, and after that we have to just take the image. After taking the image, we get the desired inverse, graph of the desired inverse of the function. Okay, now just see the example. F is given over here into the diagram, and we have to take the image now from the line y equals to x. After taking image, we get the f inverse. Okay everyone, so by this way we can find the inverse of any function if it is invertible by using graph. Okay, third, inverse by analysis. So here to find the inverse, there are two simple steps to find the inverse you have to utilize over here to find the inverse of any function. Step 1, write x in term of y first of all, and step 2, after writing x in term of y, we have to replace x equals to f inverse x and y equals to x. After putting it, we get the required inverse of the given function. Okay everyone, these are the simple steps by which we can find the inverse of the function. Okay, now see an example. Example number 1, based on to the inverse of function. Let a function defined from real number to real number given by fx equals to 5x plus 4. Find inverse. As we know very well, the linear algebraic function is defined everywhere and it is also invertible. So find the inverse, we have to put y equals to 5x plus 4. By this way we get 5x equals to y minus 4, so x equals to y minus 4 upon 5. So we have to replace at the place of x equals to f inverse x and at the place of y equals to x. So we get f inverse x equals to x minus 4 upon 5, which is the required inverse of the given function. So this is the very easy method to find the inverse of any function everyone. Okay, let's see some example. Example number 2. Let a function fx equals to 2x upon 5x plus 3 is invertible, then find its inverse. Okay, given that y equals to 2x upon 5x plus 3, so here we have to just find the value of x in terms of y first of all, by cross multiplying. After finding the value of x as minus 3y upon 5y minus 2, we have to replace at the place of x equals to f inverse x and y equals to x. So by this way we get f inverse x. It means inverse of this function minus 3x upon 5x upon 2. Okay everyone, now the third example, it is very important example. You have to just see such type of questions are important. Okay everyone, so these are the simple steps. As you know very well that first of all we have to write y equals to x square plus 9 and after that x square y minus 9. So x equals to plus minus under y minus 9. So we have to just put at the place of x equals to f inverse x and y equals to 8. But here domain of the function is positive real number, so we have to first of all neglect the negative solution. It means negative x. So we get the value of x equals to under root y minus 9. So we replace at the place of x equals to f inverse x and y equals to x. So we get f inverse x equals to under root x minus y. This is the desired inverse of the function under the given condition. Okay everyone, so by this way we can find the inverse of function and we can prove whether the given function is invertible or not. We have to write onto your copy and revise one more time at your home. Be safe, keep learning, keep watching videos. Everyone, thank you so much.